Okay, hi everybody. So let's look at this formula first. Okay, so we're attempting to have a map from the complex numbers to the complex numbers. We could even give that map a name. It should take the complex number z and send it to the complex number 1 divided by 1 minus c. Now, if you put this in a computer, it won't complain. Oops. But then, if you ever ask the computer, hey, computer, what is f of 0? Then the computer will the computer will say, that is 1. Thank you very much for asking me. And then if you say, what is f of 1? Then the computer will break. Okay, this is a cartoon of the computer breaking. Okay, and so why will it break? Well, because it's happy to do 1 minus 1. And then when it gets that done, it's going to say, okay, now 1 divided by that number, and that's when it'll break. Okay, so in other words, it's not a map from all of C, but rather it is a map from C subtract the point 1. In other words, every point in C except 1. And so if you don't like symbols, you can write every complex number except 1. Okay, so f is a map from every complex number except 1 to the complex numbers. And we're not really sure what it hits. Maybe it hits everything. Maybe, for example, it definitely hits 1, even though 1 was not an acceptable input. We couldn't input 1. 1 was an output. It was an output. An output. Wow, it's difficult to say that. Okay, let's look at the other formula. Okay, so we have this formula. Now, we're trying to make a map from C to C. We could give it a name. And it takes the complex number z to what? So first we have to understand, like, what is this even saying? Well, since we're in this class, we're going to imagine that it starts at 0 and goes to infinity. And what that actually means is that it starts, it's anywhere in 0, 1, 2, 3, 4. In other words, this is an infinite sum where the exponent starts at 0. In other words, it starts z to the 0 plus z to the 1 plus z squared plus z to the third plus ... Well, the only problem, though, is, well, first of all, you can't put this in a computer because it's infinite. But mathematically, we can think about it and say, hey, this formula does make sense because this infinite series converges whenever the absolute value of z is strictly less than 1. Strictly less than 1. Okay, and so that's our answer. It's not a map from the entire complex numbers, but rather the correct input space for this map is any z in C such that z is strictly less than 1. In set notation, you could say the set of all the complex numbers such that the absolute value of that number is strictly less than 1. Okay. It's a map from there to the complex numbers, and it has a name, f. That's all. In particular, we're not going to start k at -3. Okay, so that is this thing that you could do. It has a name even called, if you want, you can look up the Wikipedia page, Laurent series, perhaps. If you wanted, you could take k to be be rational numbers. You could look up this. This is Poisson series. I don't know. These just have names attached to it, but names aren't. I mean, other people invented this stuff too. in particular, I'm pretty sure that Newton actually invented this. But who knows, even people before Newton probably invented it in other places and other times. But, you know, we're not doing that stuff because we're scared of it. Too scary. Okay, so we're only going to do power series. Power series look like, well, what do they look like? They look like, well, we're allowed to put some coefficients in front of the powers of x. And those powers of x have to be integers. That's a power series, okay. So this is a power series. Here's something that's not a power series. Zeta of s is the sum over all the n's of 1 over n to the s. This is not a power series, not a power series, okay? The harmonic, so here's a special case. Zeta of 2 is this. This is not a power series, not a power series, not a power series. The sum 1 over n is not a power series. It doesn't even converge, but, well, okay, let's make it converge. N to the third, this is not a power series. All these are not power series, they're too scary.